Good morning, ma'am. I'm D. Lokesh Sagar from AIML B section, holding the roll number of LE10. And my topic and my presentation is about a deep dive into error probabilities in a statistical analysis. So, why qualify uncertainty, the foundation of reliable analysis? Before this topic, let me explain what is probability. The probability is nothing but it's an occurring of event uh, um, by all the occurrence of events. So the probability is mainly used in various ways, and the statistics are used in further systems. And the foundation of reliable analysis, here comes that measurements are inherently imperfect. Even the most precise measurements contains a level of variability impacting scientific theories and business decisions. Uncertainty is crucial to identify. So here the uncertainty is very crucial to identify this reliable analysis, and it's a qualifiable measure of data dispersion, essential for understanding the true range of possible outcomes and ensuring reliability of informed decisions. There are some ensured reliability in the informed decisions. When the decisions are before informed, then the reliability is very ensured. By qualifying uncertainty, we enhance the true worthing and loading the more reversed decisions and accurate data in it. And the types of uncertainty, a two propaganda approach. The uncertainty or error, the, there is a type A uncertainty. It is called as a type 1 error probability. Likely it is said to be type 1 error probability, and derived from statistical analysis of repeated measures. It occurs from random errors and variability with a data set, often calculated from the measure mean and scatter. Here is the mean and here is the scatter. Here H node is in this diagram. The H node is denoted by a type 2 error. This is a type B uncertainty error, and the type 1 is certainty. Type A uncertainty error. Type A it denotes as a type 1 error. So here the type 2 error or type B uncertainty. So arises from systematic errors, not from statistical analysis. This includes data from collaborating reports and manufacturer specializations and resolutions limit zero errors. And there are standard deviations versus standard errors. Key distinction. So what is a standard deviation, what is a standard error, and what's the mean of this standard deviation and standard error. First we take standard deviation. Standard deviation is denoted by S, and the measures how individual data points are distributed around the simple mean, uh, indicating the spread within a single data set. And standard error measurement, standard error measurements from the true value assigned by repeating the measurement process indicates the variation of any individuals. So standard error mean is the mean that qualifies how much sample means vary from the true populations, means also known as standardly uncertainty u of y. So this qualifies that how's the standard error is calculated. It is a stand error is also known as a standard uncertainty. U of it is denoted by U of it is denoted by U of I, and degrees of freedom understanding data variability. Defining degrees of freedom is denoted by generally V represents the minimum number of independent values needed to define all data points in a statistical calculations. So this it simply says that that a representation of a minimum number of independent values in a statistical calculations there should be an independent values. So the minimum number of independent values is denoted by V. Those are also called as a degree of freedom and calculated from sample size. So for n observations, if n minus 1 values and the mean are known, the nth value can be determined, resulting the n minus 1 degrees of freedom. So this n observations. So the if we need to find the mean value, then uh, it is determined as n minus 1, and the degree is also the degrees of freedom is also results as a n minus 1, and type B uncertains infinite degrees of freedom. Due to their systematic nature, the type B uncertains are often treated as having an infinite numbers of degrees of freedom. So here the type 1 error, I think that the type 1 error has a fixed value of error types, and but the type 2 error has an infinite number of freedoms and degrees, combining uncertain a comprehensive approach to achieve a robust estimate of overall uncertainty. Type A and type B components are combined, that is type 1 error and type 2 errors are combined. This is the combined standard uncertainty, which represents the total dispersion of the measurement. Here is the mean calculation for type 1 and type 2 error. Let me explain that u power 2, that's u square 2 y is equals to u square y of mean plus u square z, when it results y is a function of multiple input quantities which are which we gives the input to the probability section, and it's a standard uncertainty, that is u of y. U means here uncertainty of y. Y is the given values of multiple input quantities, and is derived by propagating the standard uncertainties of each input quantity u of x1 and u of x2 of u of x1 through the function relationship. Here the propagation is derived of u of y is u of x1, u of x2, u of x3, and so on it goes, and until u of x power xn, until it's u of xn in a type B or in type 2 errors through the functional relationship. The the normal distribution of a foundation for error analysis, the most fundamental and widely utilized distribution in statistical analysis. Okay, it's a bell-shaped curve provides a powerful model of understanding the probability of errors and spread the of data around a mean, underpinning any uncertainty quantifications of methods. So here the probability uh, containing the probability sections that are type 1 we understood from this is there will be two types of errors probabilities, type 1 error and type 2 error. Yeah, let me recap some key points. So the key points of this measuring and inherently imperfect. Certainty is crucial to identify ensure reliability and informed decisions. And here are the two types of uncertainty errors, like type A uncertainty and type B uncertainty. Here is a graph that defines that type 1 errors and type 2 error. And this is some basic definitions of standard deviations and standard errors, and degrees of freedom, understanding the data variability, how the degree of freedom is given, and how the sample size is calculated, and what is the infinite degrees of freedom, that is known as type 2 error, and some combining uncertainty and approach, how to calculate that uh, type 2 uncertainty error, what is propagation standard uncertainties, and some functional relationships we had covered. And this is the error probability of statistical analysis. And this is my PowerPoint presentation on this topic. Thank you.